Buddy Jason from Upgrade Media, and we're talking about programmatically instantiating VPCs on Amazon Web Services. And I'll bring you over here, Jason. So you're on the stream, yeah.
Yeah, perpetual mirroring.
Yeah, we're gonna pin you. There we go.
Oh, I mean, I was enjoying the multiverse.
Right. Just
one of these versions, Jason's really thin and fit. We just go through all the multiverse of Jason.
You know, I would be pretty jacked if I was thin and fit as well. That's something I'm working on, actually. There's this guy here in Spokane. His name is Nolan Garrett. He's the CEO of Intrinium. They're like a managed service provider. We used to call them, VARs before they were MSPs way back in the day, right? And he wrote this book called Fuck Me Running, talking about all of the problems that he had as a CEO and all the mistakes that he made, founding his company, and a lot of the mistakes that he made getting to successful. And he talks about how he just hit a wall, man. And I could really empathize with that, where even though I'm not in the C-suite, I have similar responsibilities, but don't have similar authority. So that's why I hit a wall recently. And it's something that for me, I read his book, and he's talking about the importance of diet and nutrition, exercise, cardio, fitness, all that stuff. And I'm just like, yeah, man. And also talking about getting good sleep and how you should get at least 7 hours of sleep a night. And so I was reading his book last night, and I went to bed at midnight, and I got up at 6, and I felt great, man.
So one of the first things I started working on back in 2011, I read Tim Ferriss's book. And there's all sorts of information in that book. Some of it really misleading. I don't mean that because Tim Ferriss trying to be misleading. I mean, people get the wrong idea. And they miss the that's actually a philosophy book. And a lot of people think it's about outsourcing and making money and systematizing your businesses, all that kind of crap. But really, it's about philosophy. And one of the things that Tim talks about is the amplification power of sleep. That sleep is a necessary part of human beings, and that you have to prioritize it. And I remember I started. Because back then I don't use an alarm clock. I haven't used an alarm clock most of the past 10 years. I don't set an alarm. If I wake up, great. So this is what it does. It creates a bit of anxiety for me when I have a meeting. It's going to be early in the day. I make absolutely sure I get to bed the night before, and so I prioritize the sleep because I'm not going to wake up at an alarm clock. And I never carry an alarm clock when I travel. I take that back. If I get jet lagged, if I'm traveling and I'm overseas, I'm like just somewhere like in a different time zone. Sometimes I'll set my iPhone for the first day. Make sure I don't sleep in too late. But that's been a real game changer for me, Phil. Like I try to get enough sleep. Now that sometimes for me that's more like 5. I'm real bad to go to bed at midnight, wake up at 4:31 to do something. There's probably some sort of mental deficiency you and I share that causes us to do that.
Right.
Bad wiring. So today we're talking about the VPC and trying to figure out. I've noticed in a lot of teams, I talk to a lot of people trying to do their own DevOps. We've overlapped a couple of those. And they seem to really be out in the rain. They don't seem to understand VPCs, what they do. A whole lot of people are on Amazon, but this isn't just an Amazon thing, right? Virtual private networks it's not a what does the C stand for?
So the VPC, a virtual private cloud.
Is it cloud.
VPC is isolated cloud resources. So, basically the whole VPC deal is having your own network resources that are represent your own cloud resources within AWS that are not shared with anybody else.
Yeah. So it's basically a container, right? It's a micro cloud container where inside of that virtual network, it has all the aspects of like a eucalyptus cloud container, right?
Of like a what?
Like eucalyptus.
I'm not familiar with eucalyptus.
Okay, well, we don't need to go into that.
Okay.
But it's basically it's like a cloud container. So you can have virtual private IDs, like if you just use private IP numbers inside of Amazon, there's actually private IPs inside of Amazon that would overlap with other private IDs.
Yeah.
Right. Like if you had 1010, like 1010.01, right? There's only one 1010.01 in the entirety of the Amazon private inside Amazon's cloud. Then you have these private containers where you can set up clusters not the right word, but groups of computers, virtual machines.
Well, Amazon, they have like the default VPCs, which normally are like in the 172 RFC 1918 address space. So there are RFC 1918 space that is that you could use to connect to other Amazon resources that are in the same like availability zone, that are in like the same availability zone. So inside of each region, you have different availability zones, and so like there's different rules for transport, and it's kind of funny. There's actually like this whole market segment and sector that's talking about like trying to figure out Amazon ingress and egress costs, because like for example, if you have resources like, let's say you have RDS, remote database service, and a VPC and worker nodes that are all in the same region availability zone, you're not getting charged for the traffic that goes between those nodes that are in the same availability zone. You're only getting charged for the egress traffic out to the internet, right? But if you do the same thing where you're talking to an S3 bucket, you get charged for the ingress and the egress. So being able to figure out, on AWS, what you're getting charged for, ingress, egress, depending upon the milieu of services that you have in your stack, is like this whole, it's this whole thing, man. And so I am not always the most savvy with that, if that makes sense. But because I'm not working typically at a scale where you run into those sorts of problems, But there are definitely IP addresses for AWS resources that are intended to be able to reach the rest of AWS, right? And so when you instantiate a VPC, the only thing that VPC could talk to is stuff that is inside of that VPC, if that makes sense, right? And you can have that VPC peer with the rest of Amazon. And like to kind of get into the code of what we worked on. It's not that.
Well, before you jump in there too far, are you streaming?
Yeah, I'm streaming right now.
Where are you at? Are you on Twitch?
I am streaming on Facebook, Periscope, Twitch. Um, yeah, Facebook, Periscope, and Twitch right now.
Okay, I'm gonna try to show this up with the Discord group.
Okay, sure, man. Yeah, I'll drop this in the Discord because I'm on that same Discord. I'll just drop the Twitch stream handle.
Oh, you're using Restream.
Yeah, I'm using Restream, but Twitch is probably the easiest one to get to. So in the DevOps channel.
Yeah, Andy Federa is over here telling you about your Echo.
Yeah, I responded to him, and he said that that's why I switched to my headphones, and that fixed that particular issue. So, man, TF.
Drop it in DevOps.
Yeah, I just dropped it in DevOps. You'll see my Twitch profile was when I got pulled over by the police on my bicycle 2 years ago. Oh. So this VPC right here, this AWS main VPC, this is one that we instantiated with this Terraform code. If anybody wanted a copy of this code, I can get it to them. It's slightly different than the AWS VPC that is on my just my public GitHub profile. In fact, I probably should, just be like, here's just a VPC instead of the whole, kitchen sink sort of thing. I probably should throw that on there at some point in time. So here, the main.tf, the main Terraform, it calls the VPC module with these attributes, right? And the providers.tf, that we require, this particular AWS provider, we pin it to a particular version. It has, these variables, access key, secret key, region. And we have a Terraform workspace that we created to manage that. Here in the main TF, I think, actually, edit, select all, copy that. And I can make a GitHub gist of it. Create public gist. And I'll drop this in the stream chat just in case anybody wants to follow along with us. And having it kind of go like that, I think that actually is easier to follow along than, oh no, VS Code works fine. Yeah, cool, sweet, that works. So with this Terraform code, we're instantiating a VPC with the attribute that's in var setter block, and that var setter block is passed to the VPC module for main TF here. So it's, setter block, it calls it. With this, it's just 10.10.0.0/16. This particular code is intended to, instantiate VPC with a /16 address space. has this little guy right here picking the availability zones, available.names, to be the first availability zone that's available in a particular region. And the reason for that is that um, with EC2 instances, you can't always instantiate every size of EC2 instance in the availability zones that are like, the less used availability zones, if that makes sense. So like, if we didn't have this local right here, it also would create our subnets. That it would have an availability zone that might not be the same for like the dev subnet as the staging subnet and the prod subnet. And so this guy right here, this AWS VPC main ID, that's just referencing what we instantiate right here. We have an attribute for VPC name, which also is passed right here, is AWS main VPC. And then when we see it programmatically on the console, it's called AWS main VPC, and that's just to show, hey, users, this is what we're calling the thing. And then we have these subnets, and there's this little attribute right here, this function CIDR subnet, where we take the CIDR block, the /16, and then we break it up, right? Now, so most people in AWS, they're only really accustomed to the default VPC. Like I just go to the console. I use the launch terminal, and also this chat is like over my face. My face doesn't show in here. So that like we just would go to the console, and instead of VPC we go to EC2, then we just click and then deploy something, right? And it would deploy to the default VPC, and the default VPC automatically has an internet gateway attached to it. But when people create a VPC, it normally doesn't have a internet gateway attached to it. Like, people don't know that they need to create the internet gateway for the VPC, and then there have to be route tables that are associated with it that there has to not just be a route table and a route, but also a route table association that is made. And so like here, what we're doing is we're just taking the subnet and we're breaking it up into these different, CIDR blocks. And we look at that programmatically there. We look at subnets, and we have a public, dev and staging, right? And so this public subnet is a /24, and it's the very last one in that 10.10.16 address space. It's 10.10.254.0/24. And the reason that we're only using a 24 there is because we're only intending on one thing, that being the internet gateway sitting in there, right? And for me, I come from an ISP background, and so for me, I always try to have the last part of a subnet, like the last available, thing there, be the uplink, so to speak. So that's the reason that I have that little nomenclature there. If we kind of span that out a little bit, then our dev subnet is 10.10.8.0/22. The staging is 10.10.4.0/22, and our prod is 10.10.0.0/22, right? So that's what those these CIDR subnet guys here do. Is it takes the amount of bits, and then the amount of network, like the bits that we use for the size of the network after that, right? So /22 is what I allocated for each of those subnets there. I'll bring that up one more time. So we have the dev, staging, prod, and we also have a public subnet. I think the public subnet, for some reason, I really probably should have the public. I really kind of hacky, real quick, refactored this that one day, but this probably should live. How's the should cut prod and public. So that doesn't actually change anything, but just for funsies, this is a AWS VPC, right? VPC. I'll save. Yeah, cool. So then I can select all and go back to my silly little thing here. We could edit it. Whoa. So get back to the top of the sucker here. So we have the VPC resource, dev, staging, prod, public, and then the attribute here is the NACL, the network access control list. And so a NACL can be a particularly frustrating and confusing and difficult thing to troubleshoot. What I find, having a really strong networking and telecom and TCP/IP background, a lot stronger than most sysadmins, is that actually troubleshooting networking on AWS is just the biggest freaking pain in the ass, man. Because so much of the magic that goes into, Amazon's, networking cloud resources, the way that the entire, suite of AWS services works, means that they had to do funky, interesting things that are not really the way that TCP/IP typically works. So here we have all of our subnets here, and the NACL is allow, ingress, egress, right? And on all of these, when we're instantiating the subnets, it depends on the VPC main. So the VPC has to be instantiated before we can do anything with the subnets. And that's really important because it can bite you in the backside, man. Sometimes you could have with Terraform, because it's declarative, but it's normally pretty good about knowing what to make in what order. But there can be some things, if you don't have the depends blocks, that you can kind of wind yourself up in trouble, right? And so then we have our internet gateway, and that VPC ID is the main ID. And then we have our route table, right? And the default route table, the main route table ID, is for the internet gateway that we just created right up here. And the default route table ID, we call it public. It depends on the internet gateway and the VPC.main. And then, the prod route table and the route table association. You have to have the route table ID and the subnet ID. And then we point everything for the route in that, production. It's called NAT GW here because I refactored this from code that had a NAT gateway and a customer gateway and a VPN and all that fun stuff. But I should probably just change that to this route prod GW. So, we obfuscated, exactly where this repo was and the name of it because it's something you're using with the customer. But at least we're updating that code as I see little bits there. And then we can later on, offline, we can go over to the Terraform workspace and see if we have to, apply any of those runs. But it shouldn't change anything that really matters. It probably would just update everything in place. So that's our production, gateway route. And then the same thing with staging. We point that towards the internet gateway for staging. And then dev, we create a dev route table. And then that route table ID also points to the internet gateway. And the route public, it goes to the internet gateway. And that's 285 lines of code here. But, that's what we're doing with it. Is we're pointing all of these routes. We're instantiating the subnet, the route table association, and propagating that route into that route table, where everything has the gateway ID of the AWS Internet Gateway ID. And so I'm pretty sure that if we were to instantiate something else into this VPC, that we still would be able to talk to other things that are in that same subnet, because the subnet should be able to see itself as the route, if that makes sense. So like we look at route tables, main VPC public. So you see it has 10.10.0.016. It sees target as local. So it does that just by default. So then it's this one isn't associated with any subnets, but each one of these has an explicit subnet association. So if there was ever any reason that we needed to point, one particular subnet at a different one, or at a different, gateway, a different route, whatever, we would be able to do that. So yeah, I've been talking for a really long time. Do you have any questions, comments, concerns, ideas?
No, not really. Some of the specific. So you're gonna put this in a GitHub gist, right?
Say again.
You're gonna put the. Are you putting some of these details in a GitHub gist?
Oh, the only thing I did with this gist was I just put it in here. So
the main TF.
Yeah, this main TF. I don't even. What the heck?
Can
Did I only have that selection? Select all. So everything that I have in here is in that repository that you have access to. I just made commits to it. So this public gist right here was just for anybody who happened to wind up on the stream who might want to follow along. So I posted this URL because this is this isn't a private repo, and we aren't going to be sharing that private repo with anybody else. But I might take this code and put it into its own repo, just because I think that having a module that creates a VPC would be beneficial on its own, even if because this all came a little bit of background, even though nobody's watching the stream. Jason had a developer who was working on one of his projects that deleted the default VPC, and then that caused difficulties where resources that were instantiated into that VPC couldn't talk to anything. And so and then when you delete the default VPC, you have to have Amazon fix that for you. And so it was quicker for us just to hack together some Terraform code to do it, and throw just a programmatic approach to instantiating that VPC. That was easier than reaching out to Amazon support without having to pay the support premium or whatever. So that's why we did this. But in the sense of having any details in the gist, I kind of just did like a really quick info dump. And there's a lot of gotchas that I learned on this, because this code took me months and months to figure out when I was building a VPN between AWS and my premise infrastructure. And so, being able to set up an IPsec VPN and tunnel, and you have to have a customer gateway. And when you're doing that with a customer gateway and VPN, you also need to have a NAT gateway with Amazon. And so that was a gotcha that I didn't learn, and then you still have to have an internet gateway, even though you have a NAT gateway. And you need to have a public and a private, like your private VLANs, you still need to have a public VLAN. And so I learned all of this over months of trying to get that particular project to work. But I think when I spun it up for you, it only took me like 90 minutes, 2 hours or whatever to refactor the code and get it up and running. So, cheers, man. Blue crack.
My only drug these days.
Same, except for the prescribed ones.
That's not 100% true. I still originally. Never mind. I don't want to trigger people that are out there that have problems.
Right. Oh, I got more issues than the times, man. But one of those things is not drugs anymore.
Well, let me go through this real quick. So the thing I was thinking we could review, and I appreciate the going through the review. I wonder if anybody cares. I'm trying to sort of attract. If there's a couple of DevOps people that want to either put their 2 cents in, or maybe DevOps wannabes want to jump in and learn a couple of things. The 3 things that are interesting to me there we go. There's 3. Three things that were interesting to me that I want to go over at some point. Maybe the best way to do this is in text tutorials. Maybe video is not the best format. I find people really respond well like blog posting and that kind of thing, because they can read through it and they can skip over the stuff they don't care about. Whereas videos, we may go on a side chain about drinking coffee and that nobody cares about. But here's three things that I think are most interesting. One is that the idea of a VPC and what that means in hosted cloud services, right? Amazon just happens to be the biggest one, but most hosted cloud services at some point deal with some form of virtualization.
Yeah, you can create your own private network. I'm not sure exactly what the term is in Google Cloud Platform and Azure, but they both have those same facilities, and that's something that's really cool about Terraform. And the reason why I hung my hat on Terraform instead of any of the other technologies for managing clouds is that it's cloud and vendor agnostic, and that there are dozens and dozens of Terraform providers. Like there's a Terraform provider for Oracle Cloud. There's a Terraform provider for Vultr. There's a Terraform provider for Linode. So theoretically, when you're writing your code with Terraform for infrastructure as code and to instantiate, cloud resources, the likelihood is that you're going to have a much easier time refactoring that for another cloud environment than you would, obviously with Amazon, CloudFormation only works with Amazon, right?
Right.
And there's also, similar faculties with Google and with Microsoft Azure that only work for those environments, but Terraform is agnostic, for all of those. The biggest problem that I found with Terraform is the documentation is just fucking terrible, man. And anytime that I need help with anything, anytime I have a gotcha, anytime I need to figure out, what am I missing? What is the part that I don't have right here? There's not you're just off to Stack Overflow and you're combing through people's tech blogs that are, 3, 5, 7 years old. And Terraform is just such a niche thing that the people who are already using it at full speed in production in an enterprise setting are just so far miles above and beyond, the people who are not quite at that skill level. And there's not really a good, it's not really like, a whole bunch of people write the Terraform blogs like, hey, look at me, I'm a technologist, hire me, I'm relevant. But that doesn't mean that they keep it up to date. And Terraform, since the last blog post that I wrote with Terraform code in it, that was 1.0.0, Terraform is now at 1.03 or 1.04, because they're an agile company with fast release cycles, and they are popping out new versions of Terraform just left, right, up, down, everywhere, right? And the largest changes were from 0.11 to 0.12. That seems to be where the biggest changes happened at. And everything that you find that's Terraform code 0.11, you just have to spend a crap load of time to refactor it, man. And a lot of times, whenever I'm out there looking for Terraform help, I find old ass code that's 0.11, and Terraform's documentation themselves is reference. Here are the attributes that are exported by a particular function. Here are the attributes that a particular function takes. But it doesn't say here's a best practice, or here's how to do this, or here is the best way to do this, or if you're trying to do X, Y, and Z, here's A, B, and C. It doesn't really do that. And that, I think, is, I think that, I don't mean to go on too much of a tangent here. Agile might be great for shipping products and shipping code, but it is the death of the technical documentation that I cut my teeth on in the 90s, man. Like, it was a completely different thing 30 years ago, um, 25 years ago, where you had all these books and they really laid things out in simple terms. And I remember, like, No Starch Press and stuff, and all the O'Reilly books. We were talking about that on not a stream, but on a call the other day. The Cricket book, Cricket Lou, O'Reilly DNS and Bind. Like, there aren't resources like that online for people who are trying to use stuff like Terraform. There is one Terraform book that I had recommended to me. Can't remember the name of it. It was made by the guy who did TerraGrunt. Getting Started with Terraform by Krill Shrinkrin. Maybe that's it. I don't know. Up to date. Detail. So who's Krill Shrinkrin? And how that's cloud expert, software developer, occasional writer, mentor, and founder. So I don't think that's the same thing. There's a guy who made TerraGrunt. Terraform Up and Running, that might have been the one. Yeah, this is the guy. Terraform Up and Running by this Yevgeny Brickman. So I've heard that this is good. The problem is that a lot of the stuff that TerraGrunt helps with only works with the CLI version of Terraform, not Terraform Cloud. And for me, I prefer Terraform Cloud. I imagine if I was in a large enough space, I might, shell out for Terraform Enterprise. Because with Terraform Cloud, everything is cloud native, so you aren't managing your own state. You aren't having to keep track of those files. You don't have to instantiate a S3 bucket to push your state out to. And GitLab CI has facilities now for managing Terraform state if you're using Terraform via the command line. And GitLab is probably something that I should be more knowledgeable at, but I'm not. I just do. I mean, I have a GitHub Pro that I pay $4 a month for or whatever. So I do everything in GitHub because I know GitHub and I know how to use it and I know how to do GitHub actions and stuff. And learning GitLab CI, if I had a job that I had to learn how to do it, I would figure it out. But with all this DevOps stuff, man, it's just such a vertical fucking learning curve all the time, man. There's just so much stuff to learn that I don't want to add more stuff than I've already figured out, if that makes sense.
Yep, it does, man. 100%. I'm a big fan of limiting services. I've got a bunch of devs that I work with regularly that I've noticed, especially younger devs, want to constantly, add a service. Like, we'll just clock in another service. We'll go buy this from these guys and this. I can't figure out how to build these servers on AWS. So let's just go pay these guys that do it for us. I don't want to have to figure out how to set up this, code a process. Let's go hire this, 20, 30, 40, 50 different service providers for a project. I mean, it piles up quick.
Mm-hmm.
And even 2 or 3 service providers, it gets kind of obnoxious. In my team, I got GitHub, and I got my CDNs, and I've got some third party solution for testing, and some third party solution for um, compiling and testing the code, and I've got some third party. I mean, it just goes on and on and on and on. So I'm with you on figure out a couple of core tools and try to limit how much external responsibilities you have. Now, I do it as an executive. I do it because I don't want to spend money.
Right.
Like every project's like, well, I mean, you take $100 here and $100 here and $100 here. Eventually, it adds up to real money. I know when it's just your account, and that's a trap, by the way, intentionally set by the guys who build these services. And I'm a guy who builds services, so I understand it intimately. I give the developer a free service. Oh, if you use this many resources, it's free. Why would I do that? Because it doesn't cost me anything. I've built the platform, right? Now you're giving me free testing and free feedback. Then you implement that in a real team where you've got 20, 30, 50, 100 people. Well, now we're getting our enterprise price schedule. So we're charging $50 a seat, not $4 a seat, right? And we've got, and then we got 50 guys. So now we're $2,500 a seat, or $2,500 for a project monthly, forever. It gets really expensive very quickly.
Mm-hmm.
So I'm with you, man. I know your logic is different than mine, because your logic is I don't learn 25 different platforms, but there's also something to be careful about becoming dependent on platforms.
So Terraform Cloud, free is 0 up to 5 users. Team and governance is 20 a user a month, right?
Yep. Which, by the way, for what they do, is not a bad price.
And GitHub, I can't remember GitHub organization pricing.
It goes to 12, and then I think the next bump is like 30.
So I right now, everything in my stack, everything that I do, I just use Terraform Cloud, and I have the free offering because I don't have more than 5 devs on any of my teams. And with my organization, my GitHub organization is free because we're a nonprofit. What else? Oh, that's really it, man. Yeah, just team and governance would be 20 a user a month. If I had 6 devs, 20, 40, 60, 80, 100 $100 a month, I mean, that would be crappy, but I get it. Time to wake up.
Get up, Phil. You lazy bastard.
So, yeah, that would be, for me, GitHub, but also, I pay $4 a month for my GitHub Pro. So if I have a repo that's just under my username, you don't get the same collaboration stuff that you get. But I mean, we bumped into that when we were setting up repos for this particular project, right? Where I had to have you put in the secrets or whatever for the Terraform API tokens so we could run the linting tests.
And we worked around that. You can be creative. You can work around, we worked around that problem by me giving you a publishing key that was in my personal GitHub account. I kind of wanted to jump on that idea that it's good to play with all these tools, and I think you should regularly get into them and test them to figure out what the best thing is, because competition yields better product. But people as developers, and especially DevOps guys, need to be really careful about developing dependencies in your deployment protocols.
Mm-hmm.
that you need to make sure that if you develop dependencies, make sure the dependency is stable, reliable, priced in a way that you can afford expansion. And Terraform is one of those things that, for what it does, is probably worth the money. But man, there's a lot of systems and tools out there that you can get yourself into, exponentially increasing your cost of development time. And you gotta balance it. The way that I do it is, this is just like using AWS images. I'd rather build my own image from scratch and deploy something purpose-built and tuned. But there's overhead involved in that, right? There's taking the time for somebody in DevOps or a developer or sysadmin to sit down and create that image, and then we have to regularly update it, look for security patches, and of course, Ubuntu / Debian based Linux distributions are really easy. So are YAM and all Yum and all those other things, but especially Ubuntu or Debian based, because they're pretty good about that patching long term. Long hauls, intentionally long service images, so they keep patching them. So you can just run patch updates and deployment. I just think people need to take that into consideration when they're thinking about tools to use. Like, do I want to be stuck with this tool? And is the company going to be around in 5 years, or 6 months, or however long my project's going to last?
Right, definitely.
I know a lot of developers just want to slam their crap together, get paid, and move on. Especially, code by the hour guys. I get it. You just want to get out there and get your product built, but have that conversation with people. Do we care that this thing may stop working in 6 months and we won't be able to patch it or update it anymore? Do we care that that we need someone on staff that understands this tool set so that we can maintain it in 2 years?
Yeah, definitely, man. And that's something that it's frustrating, and it's kind of an anti-pattern in DevOps. Everybody talks about pinning versions, and when you're working on, like a service architecture, and you have like a known good version and a release, you pin to particular versions, right? But that means that when you pin to those versions, you need to be keeping track of whatever security type stuff that is going on with that, and ensuring that you're auditing those things, and that you're keeping that code up to date, and that it's like that it's something that can be managed fairly easily, right? Like I had this one project I did the other day about Telegraph, InfluxDB, and Grafana on Ubuntu 20.04. And this guy right here is essentially the one file that instantiates the TIG stack, and you see it's using dpackage to grab this, dpackage to grab that, or grabbing it from there, then dpackage to install it. And so right now, if I was to not be keeping up to date with this particular application stack and figuring out when new releases are done, or if these particular things have security vulnerabilities in it, or if there's like breaking changes between these, like that's why there's the whole thing in DevOps about pinning versions, is because of breaking changes. It is just so easy, for a different release of software. Like an example, InfluxDB2 instead of InfluxDB1, if you were to just change that code to be Influx2 without making any other configuration changes to it, it would break the stack. It wouldn't work, because InfluxDB2 works in a completely different way than InfluxDB1, right? So, that's a thing that sucks is, when you're instantiating something, you have to pin your versions to make sure that things are stable and you don't have breaking changes. But at the same time, you still need to have the resources to be able to be doing development to ensure that you're not getting breaking changes or security vulnerabilities with the next versions of your software, right? So, like, if I was to be in an organization using this in production, I would be on the hook for subscribing to these mailing lists and being like, oh, there's security vulnerabilities for this, or automate vulnerability checking, on these machines. Another thing too is there are things that you could do with GitHub Actions where you can check vulnerabilities, to like escape, double click to exit full screen mode. Oops. That there are some things that you can do to automate checking for vulnerabilities in the code. There's this I'll paste it in the chat here. This is a thing that I saw. Terraform. Chekhov. So you could use Chekhov to check 1,000 best practices and security configurations for the 3 major cloud providers. And you can take this whole Chekhov thing and you can put it into GitHub Actions and use Terraform Scan, and it will tell you that here's some of the things that, like right here is checking tagging rules and custom policies, metadata. So, we would be able to put this whole Chekhov thing into a GitHub action and use it to check against our stuff. Oh wow, I think I might have lost YouTube. Oh, I just didn't post the comment. Weird. So yeah, man. There's some cool stuff that you can do to automate vulnerability checking, and also this is like a promoted thing. Blue bracket. Same code scanning for repository. There's CodeQL. Code scanning using actions, code scanning, CodeQL analysis. So we can configure CodeQL. Well, I don't think that would help with Terraform. Pull request checks. Managing code scanning alerts for your repository. Triaging code scanning alerts, pull requests. Configuring notifications, viewing code scanning logs. So, obviously I still have some learning to do in this space, but there are some things that you can do to, automate, checking your code to make sure stuff is secure. I don't know exactly how you would do that on, things that you've already instantiated without using something like, AWS Systems Manager, for example. And that's the thing that pinning versions is important, but then also there are, for more production type workloads and for trying to be more security conscious. There's like the sys hardened Ubuntu images. So like the Center for Internet Security, they have Ubuntu images that they can only run x86 64 workloads. So you can't use like the Graviton EC2 instances or ARM or anything like that. But you can use syshardened images, and it only costs a couple cents more or a couple fractions of a penny more per hour to use the syshardened image than it does to use the regular Ubuntu image. And I have a deployment in production at my organization using syshardened images, and it's a little bit of a pain in the ass and hassle getting used to, but it checks a compliance checkbox, and gives you a little more hardened of a infrastructure perspective, at least knowing that the base operating system image is specifically intended to be more hardened and secure than just regular Ubuntu. And Canonical does the same thing with what they call Ubuntu Pro. So you can either run the sys hardened Ubuntu 2004 image, or you can run the canonical Ubuntu 2004 Pro image, and I think that they're about the same price. And when you run that Pro image, you also get a support entitlement with it. So you can reach out to Ubuntu or sys for support when you're having issues with it. In my experience, the sys support wasn't like super duper awesome. I managed to figure out the issue before their people did. But it's always good to have support for enterprise production workloads whenever you can, and so if you can get that for just a few fractions of a penny more per hour per month, that's definitely a way to go.
You're buying an image that's been hardened. Is that what you're doing?
Yeah. So the Ubuntu Pro, that one has been. That's Canonical saying this has been hardened to sys's benchmark. And then the sys image of Ubuntu 2004 or 1804, they say this has been hardened to our benchmark. And so the difference is just, heck, we could even look and we could see the price difference. So the software is 2 cents an hour, and then EC2 is 0.02, 0.006 for T2 Nano. And so total, so the syshardened image at that size, so 46 to 66, it's not a huge difference, but it's only 64-bit x86. And then and so that's typical total price, but then we do that same thing. So you see here, software an hour is less than the actual Center for Internet Security. Oh, wait. So difference T2 micro. So they just run 0.02 cents. So basically, They have it broke down like this, right? So it's really similar in the pricing there. 0.11. So, but T2 large 0.113, 0.113, 0.206 versus 0.222. So I mean they're neck and neck, you know. It's pretty similar there.
Yeah. Well, I need to look into that. I really, we don't use those. We build our own. Like I said, I prefer to build my own images and then maintain them myself. It's a little high maintenance, to be honest, for a smaller team. I'd rather pay somebody outsourced to do that. It does get different though when you start talking about purpose-built systems and tweaking. A lot of people have this idea that you can take a generic Ubuntu instance and throw a Docker image on it and it solves your problems. Well, that's great if you don't care about wasting tons of resources.
Right.
But if you want to utilize all the resources, you've got to tweak those instances to match the resources you're buying for them.
Well, I mean, what I would do in that instance, if I was just trying to launch containers in AWS, I imagine it would be cheaper to do Fargate. If you're just doing images, then you don't have the overhead of Ubuntu. Then you don't have to do any of the tweaks that are specific, and then you're not virtualizing on top of virtualizing on top of virtualizing. You're just using orchestration, like I think like AKS or whatever, Amazon Kubernetes services or whatever. Or EKS, Elastic Kubernetes Services, something like that. That you can get your orchestration, or with Fargate you might not even need the orchestration necessarily. I'm not exactly sure as to how all that works. I actually avoid containerization of stuff right now. It's just more overhead than I need for what I'm doing. The infrastructure needs of the organization that I'm at are just fine with EC2 instances. Sometimes when you're trying to deploy like an entire stack of something, it's easier to use Docker to stand it up on an Ubuntu image. I have one particular project where I do that. This one right here, this Netbox AWS, where so we look at the cloud.init YAML here, and so this is the run command right here, where we apt-get all these things, and you see here how all the versions are pinned. I don't know if any of these need to be updated. I imagine that they do. My commit on this was February 15th, so it's been 6 months, so probably. And then we git checkout, Docker compose pull, Docker compose up, and that's grabbing this release here of Netbox community Netbox Docker. And so it looks like for them, they're on version 1.2.0, and the branch that I have is 1.0.2. So that's another thing that would need to be, updated in my dev branch, to see if it still works, pinning those versions,
Yep.
But that's what this particular project does here. Is it stands up Netbox, which is an IPAM, IP address management, prefix management solution, and it just goes out and grabs that stuff and does all that, and whammo bammo, Bob's your uncle.
Yeah.
And it was it was this same code that I used to stand something else up that was a little more, you know, just freaking getting blown up by emails and notifications right now. Urgent request. Okay, so that's something that I got 15 more minutes before I gotta clock into my real job for the day.
Well, let's call it a day, man. Sounds good.
Okay, yeah, man, sure. Well, I'm glad I got to rap with you about some DevOps stuff.
Yeah.
And we could talk after I bang out some work here. You know, we could talk probably not on stream about using sys-hardened images for some of your stuff, and maybe offloading some of that hassle that you have of putting images together by hand.
Yep.
You know, that's something that we could, you know, like we could probably pipeline a lot of that. And a lot of that sys hardening stuff, you actually, I mean, there's code where you can go out and apply those sys benchmarks to the regular Ubuntu images and get the same outcome without paying the extra however much per hour, right? But we go back and look at the prices here. I mean, for what you get, it's not that big of a deal, if that makes sense, you know? Yep. That you can go with Ubuntu Pro, and so it's built for compliant regulated environments: FedRAMP, HIPAA, PCI, GDPR, ISO, security patching, publishes images on a daily basis, and ensuring security is built in from the moment an instance launches. So, yeah, man. It's an automatic security updates applied to 28,000 packages. So that's, that Ubuntu Pro thing there, is probably better than the syshardened thing here, because it's pre-configured, for sys and everything, right? But this would be more if you're like rolling your own, but then you don't get all the extra benefits of the automatic updates, if that makes sense.
Yep.
So, it's something that, we could, we could wrap on that a little bit more later on today. I just gotta crank out some productivity, check a few things off my list, and then we could probably circle back on this if you want.
Yeah, sounds good, man.
Cool. Awesome. Well, then I'm going to shut down the stream. I hope you have a great day, man.
You too.
Cool.
Take care.
Take care.